So first, I'll introduce myself. I'm Yusra Razan. I work here as a data scientist in ذكاء. I've worked on several data science problems, but currently I'm mainly focusing on processing high-dimensional data like NLP and computer vision. Now to the challenge. So an overview of the challenge. We have three main tracks, which are the job candidate matching, a candidate background check, and the third is CV screening. If you see the definition of these challenges, you'd notice that all of them would have something in common, which at one challenge in common, which is that the process takes so much time and manpower. And here is where data science comes to the rescue. An attributes of data science is automation and augmentation. Automation where it uses AI to automate the whole process or automates parts of it to augment the human or keep the human in the loop. So I would like to emphasize the objective of this talk. To give you a technical guide on the available technologies. So this is not to give you the solution, but to open doors on relevant technologies in the field that you can use. Yes. And one important thing is to emphasize or to facilitate not reinventing the wheel and make sure that you have all the resources that you need in order to start from where the science or the market stopped. I would like to, since it's a technical webinar, I would like to emphasize on the importance of thinking of people first when designing your solution and not technologies first. Whenever you're designing a solution, make sure that it has an added value to the market. Make sure that you conduct some competitor analysis and so on. So what does the product look like? This is a general overview of the product that we'd expect. The product would, not necessarily, but this is a generalized pipeline. The product would start with extracting data from different formats that are provided in within the challenge. Examples of format would be images, Word documents, Excel, and PDFs. Then use that extracted data, use some NLP logic or build some NLP logic to structure it in a tabular format or to cluster it and so on in order to solve the challenges that mentioned at the beginning. Finally, we'd expect you to package that in a user interface or a general interface. So on this webinar, I'll be focusing on the first steps, and the third step will have a separate webinar on the upcoming Wednesday, inshallah. An overview of the data sources that we shared. We shared CVs and job descriptions. The sources of the CVs are global and crowdsourced by the community, where the job descriptions are provided by our partners, Site, Triple C, and Workable. For the background check, it's not going to be, we didn't provide any data, and it's not going to be covered here in this webinar. If you're interested in that track, you can use the APIs of the social media in order to build your solution. Now going on to the first part of the product, the data extraction. As I hinted earlier, we provided data of different formats. It can be a bit of a challenge to extract data from these formats. The first step or the first challenge that you have to solve is how to extract a raw text from different formats like image, PDFs, and web pages. There are several technologies described in the document that I shared. Things like OCR or PDF parsers or scraping technologies that helps you to extract information from several formats. Then after you extract this format, we'd expect you to apply an NLP logic to structure it, or directly use it as an input to an NLP steps or NLP algorithms. One thing I would like to highlight is that the structuring steps sometimes is not separate from the data extractions. Some data extraction methodologies uses both computer vision and NLP in order to at the same step or the same model in order to extract that information. And how is that useful? Looking at the document, you would find some useful information that would help you to structure it. Hence, combining these two steps would have an added value over separating it. For example, here, this document, it has a tabular format where if you use an OCR that has an NLP component to it, it would be easier for you to extract the key value pairs. This is a screenshot of a service from Azure. Azure OCR uses both computer vision and NLP in order to extract data and structure it in a useful format. So as I hinted earlier, that there are several technologies to extract data. For websites, you'd use scraping or APIs if it's social media. For images, you generally use OCR. For PDFs, you would use traditional PDF parsers, or you can take screenshots and use OCRs. Finally, for Word documents, there are a couple of APIs that can help you. For example, docx is a Python API that you can use in order to extract data from documents. Also, you can take screenshots of the document and use OCR. Yes. For CSV and Excel, it's tabular data, hence a Python package called pandas are going to be useful for this. Okay. So one added value of using OCR over traditional parsers for PDFs and so on is that these documents or CVs, for example, would have varying structures and so on. Hence, using an OCR or a deep learning method or training a deep learning method to learn on different formats would solve that issue versus using the traditional PDF parser. So what is an OCR? OCR is a deep learning or an AI method that analyzes and extracts text or information from an image, usually, and returns it in a machine readable format as an Excel or JSON. This will help us structure the data and then parsing it or applying NLP logic to it in the next step. So this is shared in the documents that I mentioned earlier. There are a couple of packages for OCR. One of them is Keras OCR. It's a Python package that is free and accepts images and accepts images. If you have PDFs, you can write some Python logic to it in order to convert PDFs to images and to be accepted by that. I'll be showing you later in the demo on how to do that. We also have several cloud solutions like Azure, Google Vision, NanoNet, and AWS TextRact. All of them are priced, but I think it's a good option to start with to prototype your solution. Some of them allows that key value pairs extraction like Azure and AWS and NanoNet. For data formats, it accepts both images and PDFs. So as mentioned earlier in the document, when to use cloud versus open source. So cloud, I think, is ideal to build a prototype to test at the market because it's a quick solution where you can access an API and helps you test the business idea quickly. And if you've validated your business idea, you can invest later on building your own model to cut costs. Okay, the only scenario or a good scenario where you can start with open source over cloud would be that none of the cloud solutions are performing to what you're aiming for or what you're aspiring for, and you want to build a better model or build a better OCR in order to build a better OCR as an added advantage to your business. Okay. So I built a simple demo on some of the concepts for reading and extracting data. Yes. So if you have a tabular data like the workable file that we shared with you, you can use pandas package in order to read it. The method is simple. It's just pd.read.csv and you insert the directory. PD is the PD stands for pandas. We defined it here in the import. If you want to read an Excel, it's the same format, but with pandas, but with read Excel. The issue with Excel that sometimes it's formatted, hence you'd have to write. You'd have to work on fixing the format issues. For documents, you would use docx. Here is an example on how to use it. You would share you would input the directory. So this notebook is going to be shared with you in order for you to use some code snippets. When you read the document, you can access the number of paragraphs read in that document. Finally, if you want to convert, if you want to use, for example, Keras OCR or open source OCR, and you have on PDF images, you would want to take screenshots of the PDFs or convert it to images, then process it using Python or using the open source model. Here's as an example of on how to do that. So we'll be using PDF to image package. specifically the function of convert from path. You pass to it the path, also the DPI, which is the دقة. Then you would iterate over the pages. Then you'd iterate over the pages and take a screenshot with it. And I'm saving it in this directory. Also, then I'm gonna read whatever I saved in the directory. Whatever images I created here into this variable. So if I run this, so this command would allows you to write a terminal command, and I'm writing here a Linux command. So I saved all my converted images into a variable called image directory as a list. Going on to the next step, here I'm showing, I'll quickly go over to two APIs. One is AWS recognition, which is the OCR service from AWS, and the other one is Google Cloud Vision, or OCR. Both of them you would have to have your credentials in order to access it. For AWS, I'm not gonna run it, but I'm quickly gonna show over go over the code. You would use Boto as an API in order to access the service, and this, simply you'd loop over the images, which is the image. Which is shared here in the image directory that I saved earlier. Then the API would return the annotations from AWS model and would save it here in JSON. Google follows similar logic. I'm not gonna go over it, but I'm gonna share the code in order for you to reuse. So moving on to the second step, which is building the NLP intelligence. So I'm gonna start with the simplified NLP pipeline of NLP. Almost any NLP task starts with, generally has these three steps. One is text pre-processing. The other one, the second is word representation. Then finally the modeling. Modeling could be supervised or unsupervised. Supervised when you have a label or a target that you want to predict, and unsupervised when you don't have a label or target, but you'd use some mathematical logic in order to study the similarity between the input. For text preprocessing, here is an example of how text preprocessing happens. Usually text preprocessing, we remove any unnecessary information for the model in order to, we would basically remove any noise for the model. And this step heavily depends on your end task. So it differs from task to task, and the decisions here heavily depends on your task. Examples of pre-processing that can be done would be removing explanation points or removing components that are not important to the task that you're gonna do. We'll heavily go over the different techniques done in the pre-processing step. So after doing pre-processing, we'd have word representation, which is converting the text into a representation understandable by the algorithm or the machine. So the algorithm doesn't understand text as humans do. But if we represent it in a numerical format or in a graphical format, it would know better on how to handle it. Then finally, if we convert it to that representation that is understandable by the machine, we can use the modeling algorithm. So for pre-processing, what are the different techniques? There are around 6 different techniques of pre-processing. The first is removing any irrelevant elements like HTML tags and so on. The second would be normalization. So what is normalization? Normalization meaning converting all the text into lowercase, and the reason for that is in computers the capital and small are represented in different ways or different Unicode characters. So in order to reduce that variation that doesn't have much meaning to some tasks, we'd convert it to lowercase. Also, we'd remove punctuations and space if it doesn't add information to our end task. Finally, tokenization. Tokenization is basically splitting words into sentences or into tokens or words. The fourth method would be word removal. Usually, with word removal, we'd remove frequent words that doesn't add much information or doesn't add much information to the end task. Examples of these are frequent words like to, of, and the. If you'd wanna do topic modeling, these information wouldn't tell us anything about a topic as they are very frequent. Part-of-speech tagging. It's basically the task of tagging a word into its grammatical part of speech. For example, here ذكاء is a noun. We tag it as a noun, and the added value of this is to add some semantics to the text. The final step that we can do is stemming. Stemming is basically converting the word into its stem or root word. And the added value of this is that sometimes we don't care, us human understand that قال قالت قالوا means the same thing, but for computers, since it has different spellings and so on, it doesn't know the difference. So it's very useful for some tasks. Now into the second step, which is word representation. Word representation is basically the task of converting high-dimensional data into a relatively low numerical representation. Examples of high-dimensional data would be images, audio, videos, and text. And in order to, many of these dimensions are not useful to our end tasks. So converting it to or extracting the useful information for the model to learn on is useful. Example of embeddings would be word embeddings, where every word should have a vector, where every word is a is represented by a vector associated with it. For example, here the word king can be represented, or the word embedding of the word king would look like this. It's a series or a vector of a numerical vector of that represents the word. So that vector represents an approximate meaning or semantics of that word. Here is an example of a couple of words with its embedding. You'd see that similar words would have similar meaning. Hence, that embedding is capturing some meaning in that word. For example, man and woman have this parts in common, where king and queen have this parts in common. A cool thing about embeddings is that it allows you to do arithmetic information on it. For example, if you take the vector king, then subtract to it the vector man, and add to it the vector woman, you'd get a vector that is very similar to the word queen. And that can be applied in Python as well, which in a package called Jensen. In the demo, I'm gonna showcase it, inshallah. So here is a word of here is a line code of Jensen. We added two vectors, which are king and woman, and we subtracted man. And we queried on what is the queried the model on what is the most similar to the result of this equation, and the number one result was a queen with 85% similarity. So as highlighted earlier, embeddings capture similarity and analogy. So okay, what can we do with embeddings? Embeddings after extracting embeddings, you can do two things with it. One is either to input it to a neural network, then train that neural network for a classification task or an NLP classification task. The other is apply a clustering or similarity metrics upon it in order to extract some value out of it. So both supervised and embeddings can be used for supervised and unsupervised tasks. Pros when to use embeddings. Embeddings is considered to be faster to train or more costly efficient compared to WordNet, which also captures the semantic information. It's also considered a standard approach where we usually represent words before doing any NLP steps and embeddings. One cons of embeddings is that each word would have a single vector regardless of its meaning in context. For example, the word ذكاء could be used as in the context, or it could mean different things depending on context. It could mean cognitive intelligence, it could mean business intelligence, it could mean artificial intelligence. However, for ذكاء, we'd have only one vector, and we wouldn't know the difference between if the word appears in different contexts. A modern approach solves this issue, which is transformers. Example of transformers would be the infamous BERT algorithm. Another issue or another kind of embeddings would be it's very memory intensive, as you represent each word with a vector. Finally, it's very corpus dependent. So for example, in this competition, I would advise you to build your own embeddings on CVs rather than user rebuilt one, because it's corpus dependent. So the closer the data to the end task, the better. Okay, so embeddings is like a class of algorithms. There are several common examples of embeddings. One of them is global vectors. The other is fast text provided embedded by Facebook. And the third is word to vec, which is basically representing each word in a vector. We could not only words that we can represent in embeddings, we could also represent a whole document in embeddings, and for the goal of clustering documents or seeing similarities. And I think this is going to be super useful for our challenge, as you can see similarities between, for example, candidates and jobs, or you can cluster different CVs and so on. So as highlighted earlier, doc2vec is basically representing a whole document in a vector. It's in terms of scaling, it's very similar to word2vec. I'm gonna explain it in a bit. Also in terms of the packages that it implements it and so on. So embeddings is basically the output of a neural network. These details won't be much useful to you, as it's and the final package is going to be encapsulated, or it's going to be abstracted, so you don't have to worry much about it if you didn't get this part. So yes, embeddings is the output of a training task. You basically where the output layer or the target is the word that you want to represent, and the input would be the context words beside that are closer to that word that you want to represent. This is iterated a couple of times, and the resulted weight matrices here can be used, are the embeddings that we'll extract later on and use. For doc2vec, it's basically the same process, but you input a document in the input layer. You input a document to differentiate. You input a document to differentiate where this word appears. So when you train a doc2vec model, you not only access the word embeddings, but also you'll access the you'll not only access the documents embedding, but you'll also get a word embeddings with it. Okay, so we represented the text in or documents and vector format. What can we do with it? One thing that we can do with it is apply similarity to it, or apply a unsupervised task to it. There are several methods or several similarity distance measures that you can apply to vectors. Example of those are cosine similarity, Euclidean similarity, and Manhattan. The most famous out of these three is cosine similarity, and I'm going to focus on this. So cosine similarity is basically measuring the angle between the two vectors. So the angle would be closer to zero if they're the angle would be closer to zero if it's if the two vectors are very similar, like here in the example Italy and France. Hence the cosine similarity output should be close to 1. The outputs would be very different if the degree is 90, hence the cosine would be closer to 0, and the two vectors would be similar but in opposite directions if the degree or the angle between them is close to 180. Hence the cosine of that angle would be close to -1. So doc-to-back linked with or doc-to-back linked with or used with cosine similarity is the first unsupervised technology that we can use to solve our problem or our challenge. Another method that we can use is called topic modeling. Before moving to topic modeling, I'm going to show you the demo. So another thing that I did that I think is going to be useful for the task is first I wrote a function to convert JSON file into pandas. If you're familiar with pandas, I think it's going to be easier to work than JSON. Another thing I did is write a language detection function. So using regex, I'd detect if the document have Arabic text or not. And I would use that function in order to filter CVs, Arabic CVs that are submitted during the crowdsourcing process. So here I applied it, and I got 38 to around 38 of the documents have the Arabic text. Also, you can use, I think some of the cloud services has an API that detects the language. Also, I think Google Translate might have something similar to this in order to detect whether the text is Arabic or English. So here for the regex, I'm listing all the Unicode letters of the Arabic language. If the pattern or the text doesn't have any Arabic text, it would classify it as English. Otherwise, it would return Arabic. So for word-to-back, we'll be using GenSim in order to train and also use it for the similarity measure. Here I defined a couple of data. It can be you can here pass the extracted text from either the job description or the CVs. For the sake of the demo, I used dummy sentences. After that, we'll apply pre-processing, where we'll tokenize the words. So after tokenizing, each sentence would look like this, as well it will have a tag. As we're doing doc-to-back, hence we'd want to have an ID for the document to represent it. After that, using the doc-to-back function from GenSim, you'd create a model. Then build a vocab where you pass to it the tagged paragraphs or vocabulary that we just created. Then finally, we would train and save the model. So this is, I already did this. After training the model, you can load it using this function from the doc2vec object. Make sure that whenever you predict that you use the same pre-processing steps that you use for training. Here I'm testing on this sentence, and I'm using the same pre-processing steps. I'm using this to predict or infer on the test sentence. With this variable, I'm printing the embedding that resulted from the test, that resulted from the prediction. Also, we can use this in order to query on vectors that are similar based on what we trained on. And here you'd get the tag of the most similar, and along with the similarity score. So as we mentioned, if it's close to either 1 or -1, it's very similar, and if it's close to 0, then it's not similar. So the difference between -1 and 1 is the direction of the relationship. One thing I would like to highlight is that you can visualize these embeddings or these vectors using Tebnي or UMAP, which are common visualization methods and for high dimensional text data. Also, they're used for images as well. Moving on to the second unsupervised method that we can use in this challenge, which is topic modeling. So what is topic modeling? Topic modeling is basically unsupervised tasks of extracting topics found in a set of documents. So you can think of it as a structuring steps where you have a couple of documents, and you'd want to study the similarity between these documents and or categorize them, and tagging, building classifier for that task, or for your case is very expensive, and you would want to use an unsupervised method. Hence, topic modeling is suitable for that situation. There are a couple of algorithms that can be used for topic modeling. The most famous one, or the standard one, is LDA. So how does LDA work? How can this algorithm extract topics? You'd have a couple of documents, for example, CVs, and you'd have a couple of terminologies or text found in these documents, represented in another dimension, and you'd calculate the co-occurrence between these two. Then, if you have these two information, LDA is basically, how does LDA work? LDA is basically a matrix factorization methodology, where you give it a topic, or where you give it a topic length. For example, you tell it, okay, cluster these documents into 5 topics. Then it would factorize this matrix into two matrices, depending on the number of topics that you passed. One important thing that I'd like to highlight is that LDA doesn't tells you what the topics, but you have to figure it out from looking at the relationship between the documents and the topics, or the topics and the words. Another important thing is that the number of topics is defined by you, the data scientist, and it requires some fine-tuning in order to find the most suitable number of topics that results in meaningful cluster or meaningful topics. Another thing that I would like to highlight is the removing noise or the pre-processing steps usually helps a lot in achieving a better model for this algorithm. So as I highlighted, the advantage of using an unsupervised method is that it's relatively low cost method to cluster or to get an overview of large documents. I think maybe using this algorithm, for example, in order to build an interface for an HR employee, where an HR employee has, for example, a lot of CVs, unstructured CVs, using such algorithms would help the employee get an overview of the candidates that applied, for example. So for topic modeling, we'll be using sklearn. And for this example, I'm going to be using, I will be using workable job description. And the reason for that is I have the categories. I think it's easier to specify the number of clusters or the number of topics that I want the algorithm to be aiming for. And here I calculated the number of categories in this data set, and there are around 26 categories. Example of these is accounting. Then I combined three columns, which are the responsibilities, the job brief, and requirements, in order to get more vocabulary. And I expect these compared to the category to be to have similar vocabulary. Then I converted the document. I created the document and term matrix that I showed in the presentation using the bag of words method. Then passed that to TF-IDF vectorizer. Then finally, I used this matrix in order to fit. I created a model using this function, and I passed to it the number of components, which is the number of topics that I mentioned earlier, and the random states in order for reproducibility. Then I passed to it the matrix that I created in order to train or fit it. So for topic modeling, one useful package that you can use is called PyLDA Viz. It allows you to visualize the the relationship between the text as well as the documents, the different documents, the different topics that you have. For example, here are this is the result of the model that I have. I passed this object to this method, and this is the result. Here it shows me the most common words or the most silent terms in this corpus. Or then it shows me the different topics that it has created. When I hover over a topic, it shows me the most relevant words to that topic. For example, for topic 1, you'd see the relevant word would be company, clients, customer, business, management, operation. For the second topic would be technical, software, applications, security, code, design, computer. So we can see that this category is computer or technical related, where here is more business related. Here, travel, suppliers, insurance. Okay, another useful method is the named entity recognition. So named entity recognition is a classification task or a supervised task where a model is trained to classify a named phrase into a predefined categories. For example, you'd give it ذكاء, or you'd give it, for example, the word Aramco, and the model would predict that this word is actually a company name. This model is very common and very useful, has a lot of business applications. One common application is in chatbots. Chatbots heavily depend on this model. Also, if you want to structure unstructured text, such task or such model is very useful. One thing to highlight is that named entity recognition is usually dependent on detecting a named entity, or detecting that the word is actually a name before detecting what kind of name it is. So for example, here in this sentence, you'd have two names. One is burrito, and the second one is this one. So you can build a classifier to detect that this is an entity and this is not an entity. Then pass that entity words into an entity classifier or an NAR. Or you can use part-of-speech tagging models in order to detect which words are nouns, then pass the nouns to the NAR. As I mentioned, that NAR or named entity recognition is a very famous task or a very common task, and you'd have actually a lot of options to use this model. There are a lot of pre-built models and cloud solutions like AWS, IBM, Azure, and almost all of them. Also, you have the option, even in the open source packages, NLP packages, you'd find pre-trained models. So as a rule of thumb, I would advise you to use any pre-built models unless you would want to detect more granular information on the named entity. So when we go back, the named usually the categories of the named entity is not granular enough, and maybe you can build a model in order to predict a more granular output. For example, here person, you could say مثلا female, male. You can if you want to detail this class, we can divide it to female, male. We can say that we can add things relevant to our challenge. For example, we will build an AR to predict whether this word is actually a skill, or this word is actually a technical skill or a soft skill, and so on. And the pre-built models, you wouldn't be able to predict to that granularity. However, you can reuse these models in order these learned models, and then start from it or fine-tune it. Start from it or fine-tune it in order to get a more detailed one. So in the demo, I'm showing pre-built models and the output of it. However, if you're interested in fine-tuning an AR model and so on, or if you have any questions related to applying any of these, at the end, I'm gonna be I'll add a link to our Slack channel at ذكاء, and you can ask any questions, and I'm gonna be active in replying to you there. And if there is any need, we can jump into a video call in order to jumping into a video call in order to give you hands-on support on this. So for AWS, it has an AR model. It's under the Comprehend API that they have. I took one CV output, or also CV content, and passed it to the AWS API, and this is my output. You'd see here. This is not. So you'd see here that it's not only it's working well on Arabic, but it will definitely work better on English. So here the Abdelaziz Bakht Al-Amri classified it as a person name, and this is the confidence score of it shows how confident the model that this is the correct class or not. And here it classified it as a date with lower confidence score. And الاتحاد السعودي للأمن السيبراني classified it as organization. You see here the tokenization is not quite correct, but generally it gave it the correct class. Also شركة نسمات مكة الفندقية, it gave it the correct class. And the number gave it as other. The second API is Spaces. Spaces is an open source where not only you can access it for prediction, but you can also download these models and fine-tune it depending on your end task. So for Spacey, I created an object of a language model. I passed to this object the text that I wanted to be parsed. This is a sample of the text that I passed. نزيها الشجاع العثماني, associate professor, King Abdulaziz University. So I applied it. So here I'm printing the output of the entity recognition model. You'd see that it classified Naziha as a person, which is correct. Also, this classified as organization, which is not correct. Here, maybe with some fine tuning, we can make this model better for our end task. King Abdulaziz, organization correct. Jeddah GPE, I'm not sure what this stands for. Organization, this is not correct. We can use this model in order to improve it for our end task. So out of the three methods that I described, I would say that NAR, I think NAR would be the most accurate as its classification method. However, if the pre-built ones, it might require some data collection, labeling in order to reach a good accuracy. So in terms of cost, it might be more than the unsupervised methods. Okay, for the last step of our product, which is the business logic or the UI, here I think it would, you think of the customer experience and so on, and maybe you would provide an API for developers and so on. So for this part, we'll have a separate webinar on Wednesday, so stay tuned. I'm just gonna go over I'm just gonna mention a couple of prototyping tools that I think is useful. One is Plotly Dash, which is Plotly Dash and Streamlit, which are both prototyping tools for AI-related applications. It allows you to embed Python packages right in there. Both of them use Python, hence if you're a data scientist that don't have a good experience in web development, it's a good tool to start with or reach a quick MVP. I have a comparison I added in the document that I shared in the Notion document. So in the Wednesday webinar, we'll talk about Plotly specifically. One thing I would like to highlight, which is not mentioned in the document, and we want to talk about it in the upcoming webinar, which is Raza. So if you wish to build a chatbot for this challenge, maybe to add a user experience enhancement for the HR employees and so on, or for any human component in that. Raza is a nice package in order to quickly build a chatbot. Finally, so I would like to invite you to join our Slack channel. All the resources will be shared there. Also, further questions will be discussed there. And if you need if the Slack is not enough, and if you need more, we can jump into a consultation call if needed. So maybe you can Slack that, capture that QR code and join. I'm gonna leave this screen on for a while. So there is a question on whether you should use Arabic data or English data or any language or any other language. I think you should start from your product or the customer that you'd want to target. Do you want to target, say, the segment that writes Arabic, that uses Arabic data, or the segment that uses English data, and start from there? Both is fine. Both are fine. But we shared English data as we think that more people write CVs in English or use that kind of a process in order to apply as opposed to Arabic. So there's a question on whether I recommend extracting data using OCR. Can I share some Keras OCR model? I didn't get the second portion. So Keras OCR is basically a package that that encapsulates some OCR models that had good results in research. The nice thing about Keras OCR versus Cloud is that you can use that model and fine-tune it in order to build. If the Keras OCR has some issues in the documents that you have, you can reuse that model, retrain it on your data to reach a better result. I'm not sure on whether Keras OCR has good performance. I haven't on the CVs. I haven't evaluated that. But generally, the model had good accuracy. So there is a question on whether you can watch the webinar on YouTube. So we're gonna upload it in Slack. Maybe you can join Slack and we'll share it there, not YouTube. So there is a question whether you can use a data set that is different that we gave you. Yes, of course. So in this challenge, we're not limiting you to using the data set or anything. Remember that it's a business first challenge where okay, we care about how well your technical solution is built, but what we care most about is the design of the product, whether the product would have a market and so on. So think of that objective first, regardless of the technicalities. So on credits, as I mentioned, there is nothing pre-planned. So the default option is no. But maybe I can check, but I don't think so. So I'd like to highlight that we reached the end of this session. So if you don't have any questions, maybe we can close the webinar.